Glad you could join today's Q&A with Innovators and hashtag Black STEAM. I'm Gerard. Let's get inspired. All right, welcome everybody. My name is Gerard Buckner with the Mortgage Institute for Research as part of the outreach team in the Discovery Building. Today's conversation, we will be touching base with Professor Ashton and talking a little bit about his background and his lab and things of that nature on the UW-Madison campus. As we are having this conversation, if you guys have any questions, comments, anything of that nature, please tap onto your social media and use the hashtag Black STEAM Innovators, and we will be sure to check those on multitudes of platforms and be able to touch base with conversations and answer any questions that may be out there. So awesome. Professor Ashton, thanks so much for taking the time to talk with us. I'm really excited to have this conversation. We've never actually had a conversation before and met, even though we're in the same building. So do you want to take a little bit of time to kind of introduce yourself and what you do, and then we'll dive in?
Yeah, so my name is Dr. Randolph Ashton. So I've been at the University of Wisconsin since 2011, and I run a lab in the Wisconsin Institute for Discovery. And our main focus is developing stem cell technology so that we can cure diseases and disorders of the central nervous system.
Awesome, cool, thank you for that. So yeah, the basic of the basic questions. Where are you from?
So I was born in Philadelphia, but raised in Richmond, Virginia. And that's, I guess, technically where I'm from. I went to school in Hampton, Virginia, and then upstate New York, and then out to California, and now in the Midwest in Wisconsin. So I've been all over the country, really.
Yeah. Where's your favorite part of the country?
I mean, home always has a sentimental value, right? So
I was expecting home or California.
No, California is great. Every place has its pros and cons, and Wisconsin is great as well. But home always, I guess, will win out.
Awesome, thank you. So yeah, kind of touch base. Everybody wants to know, how is everything going for you, and work-wise and even personal-wise with the whole pandemic.
Yeah, so COVID-19 is a tragedy that really didn't need to be as bad as it is. But, in terms of the lab, it caused restrictions on our work, basically because we could only have a certain number of people in a certain square footage of the lab. So people were limited in how much work they could do. And so that has continued really for safe practices. I mean, my lab members, grad students, postdocs, and research scientists, they're the brave ones. They go into lab and still get the work done. Fortunately, we haven't had any cases in the lab, and so that's been great. Personally, I mean, everybody's life was disrupted, and so I have two young kids, right? So they have been with us, and we had to sort of change around our childcare arrangements. And I've had several people in my extended family, both myself and my wife, who have passed away from COVID-19. So it is something that has been a tragedy and unexpected. But there have been upsides to it. I eat lunch every day with my kids, so I've seen them a lot more. And everybody's in the house at home, so you see everybody in your family, your immediate family, a lot more. So that's been nice, outside of sort of the tragedy with extended family and stuff. So fortunately, we've been able to not have any COVID-19 in the house. So that's been a real blessing.
Well, sorry for your loss, but I'm also glad that you are able to see the positives into it as well. But yeah, so yeah, you kind of already talked about the lab and like what you do. What is the current, I guess, research that's happening in the lab? What are your students trying to discover and do with stem cells?
Yeah, so we basically, stem cells in the body, right, are embryonic stem cells. So they have the ability to give rise to all different tissues, and they undergo, this amazing collective morphogenesis process to actually form the tissues of our body and the body as a whole. So we basically are trying to understand how they do that. And that's building off of almost centuries of developmental biology research, particularly how they do that to form the brain and spinal cord tissues. And we basically try to take the knowledge that is from the developmental biology literature, meld that with engineering, and take the stem cells that we grow in the lab and put them in similar environments to understand various cues that are necessary to orchestrate the process of tissue morphogenesis or formation of the brain and spinal cord tissues in a dish. And so we're basically trying to make models of human brain and spinal cord development using these stem cells that can be used to better understand how things can disrupt that process and lead to congenital birth defects, as well as chemical compounds that are toxic for that process, just for keeping everybody safe from all the chemicals that we have and have in our commercial environment and come into contact with every day. And then we're also trying to take that technology and those tissue models to look at disorders or diseases that are caused by various genetic mutations, which we can induce those same mutations in our cells, or get cells from patients that we can convert back to an embryonic-like state. And now they'll have the embryonic capacity, but also have the genetic mutations that were in the patient. So those are the ways that we attack that problem. But our main sort of expertise is really how to try to build these tissues, right, and then apply them.
How many students are in your lab, and do they all do like some of the same thing, or does everybody have like their own kind of process to be able to get to that end goal?
Yeah, so right now we have 5 grad students, 2 postdocs, and 1 lab manager or research scientist. So the lab is actually quite interdisciplinary. We have a fair amount of biomedical engineers, we have some material scientists, and we have some neuroscientists. And so kind of the people that you would expect to be necessary to execute that process. And everybody has their particular skill set they come with that makes them more suited to do different parts of that tissue building process. But overall, the goal is that the lab is interdisciplinary, and the scientists also within the lab will expand beyond their own expertise to learn skill sets in other disciplines as well. Now, we don't expect a biologist to do mathematical modeling, right? Or we don't expect, although some can, we don't expect the engineers to necessarily go deep into genetics, right? But the biologists can learn how to do some of the surface chemistry, following a protocol and understand the chemistry behind it. And the engineers can learn how to do various stem cell differentiation processes. So everybody's pushed to be interdisciplinary and widen their own skill set, but definitely people are better suited for different sides of it.
Wow, that sounds super deep. I'm trying to process like what that looks like on a daily basis, even though I'm in the building. It's still super cool to hear. And like what got you to this process of being a professor and like in tapping into stem cells? I mean, I'm pretty sure there's probably other subjects that you teach and learn, but yeah, what was that process?
Yeah, so it's funny you asked that because it's a funny story. I've always been interested in math and science. So when I went to college, chemical engineering kind of mixes the two. So that was the discipline that I chose to learn about. And that was a great choice. Chemical engineers are basically responsible for taking all the natural resources that we have and converting them into products that you currently use, the clothes you wear, the food you eat, the materials that are used to make your computers and stuff like that. So chemical engineers can play a role in all of those different processes. So it's a really cool discipline. And really when I was in undergrad is when Jamie Thompson discovered how to derive pluripotent stem cells. So Jamie Thompson is a researcher here at UW-Madison. So UW-Madison has a long history in the human stem cell field. And I, read a Time magazine article, or somebody gave it to me because I didn't read Time magazine regularly when I was in college. But somehow I got wind of that and read the article. I said, oh, this is great. And this, can change the future of medicine. So since then, I've always been interested in stem cells. And from college, when I went to grad school, I chose a lab that was a chemical engineering lab, but working on interfacing materials and stem cells. And really the thought behind that is stem cells in the dish that we culture them in they reside in an environment that we largely construct. And so if we can construct that environment to direct the stem cells to do a particular processy, or to differentiate, meaning turn it from a stem cell into a different type of cell, if we can direct that process, then we can have a lot of control over what the stem cells do and be able to harness their ability to create cells and tissues that can be used for medical advances. So it's the same basic process of taking this natural resource of stem cells and trying to figure out the processes that you put them through in order to get the final product that can be used for medical advances. So it's very still chemical engineering in its conceptual sense, but it's just applied to stem cells. And that's what we've been doing ever since.
Awesome. And it kind of make me bring it to like a different question. So like typically, especially in the STEM world, I mean, as Black men, as Black people in general, we don't necessarily get to always see that. So it's awesome to one, see a professor, and then two, somebody that's heavily into the STEM field, as, while being in Madison, Wisconsin, because you don't really see, really much of that at all. So,
Yeah.
so like for you, like what does it mean to be Black in this work of one, being a professor, and two, being heavily into the STEM field?
So there are not a lot of African-American professors in the field. There are some, which makes a nice sort of tight-knit community in a sense. But I mean, as you excel in whatever discipline you do, I think it's a natural occurrence that there are less and less people that look like you, especially if you're a minority. Because those career avenues have for a long time been populated by the majority, and now the minority is making its way into those fields. So you build your network I think you should have it with both minority and majority people in your network to help support you and champion you along, and that becomes your community. So the hard part is that there is always this imposter complex, because you're the only one that looks like you in the field, and the only way to really get around that, because you never really get over it, is to get around it, is that you just put your head down and do the work. And as you start to realize that, hey, you can do this work, which all of us really can, you can do this work, then you start to overcome that imposter syndrome, or at least learn how to push it to the side so you can get your work done.
Absolutely.
Now, there is the reality of it is that there are multiple studies that have come out saying that African American or minorities who submit research proposals to the government, submit papers, have a harder time getting things funded or getting papers accepted, due to just implicit bias that is there in all decisions we make. So that's the reality of it. So you take that and you just understand that you might have to, instead of submitting 3 proposals like your majority colleague, you might have to submit 5 to 6, right, to get something funded.
Yeah.
And it's not fair, but that's how things are for any minority that pushes into a new area. So, as long as you have, I think, a good level of confidence in your abilities, and are expecting the environment to be that way, then it becomes much more feasible for you to sort of push through it. And that's how I was raised. So my grandfather was president of the NAACP of the state of Virginia, and so they were always. I was raised with a good background in my history, or the history of African Americans in the United States, which gave me pride and confidence. And then my parents always pushed me, and so that gave me even more confidence in my capabilities, and educated me as to what it was like to go out into the world, where you are no longer amongst everybody who looks like you, but you're put in situations where you're one of 100 or 1,000, and you just have to sort of persevere and push through it.
Awesome. It's really cool to see. I love it. Knowing that, like, being able, especially in the building, there's not too many folks that are a minority. It is a major majority, and it's cool to be able to see those that may look like you, and then be able to, hopefully drive you to be able to change that situation for the future. So I hope that, I'm not going to be a professor, I'm going to be honest, but hopefully somebody else that watches this video today is inspired too. So thank you. And you kind of already talked about it, about like kind of your upbringing and like your grandpa and how your parents pushed you. So like what was it about you as a kid or in middle school and high school that you knew that like STEM was going to be your way of life, or like, or what process? What did you originally start off with thinking you want to do, and how did you go until like getting to the point of the Time magazine and being like, all right, stem cells is the way to go?
Well, as I said, I was always, had a knack for science and math. So even as a little kid, I mean, I was, exploring things outside in the yard. My parents got me a little microscope. I was shocking crickets in the basement with aluminum foil, learning how electricity worked. So I was always curious in that sense. But we also did every season we did sports. My family is big in sports, and we also did music. So I contributed a lot of the success to my parents. They raised well-rounded kids, right? So we all did sports, we all did music, and we all were told and required to do well in school. So I mean, as you're going, for the kids who may be watching this, as you're going throughout your K through 12 education, you understand which topics you're more interested in, and which ones come maybe more easily to you. And I would encourage you to delve into that, and figure out, which career opportunities are available. Talk to your high school counselor for people that are focused in these areas, and find what's interesting to you, find your passion, and then work hard at it. So your job, once you leave, your job when you're a kid is school. When you leave school, you have started your career by and large. So once you go to college, the academic record that you establish in college will either prevent you or allow you to get to the next step, right? And so that's, you started your career. And then once you go from college, you apply to graduate school. To college, you get your bachelor's, for, if you're in sciences, bachelor of science. When you go to graduate school, you're going either for your master's or your PhD in whatever your field. Or you go, if you're a doctor, you go to med school. If you want to be a lawyer, you go to law school. And so at that point, you're really pushing to the terminal degree in your field of interest. And again, it's just hard work, learning as much as you can learn about your craft, right? As LeBron James says, you learn your craft, and you work on it throughout your career. And so that's what I did when I got my PhD from grad school. I got my PhD in chemical engineering, but I was again interested in the applying chemical engineering to the biological sciences. So then if you go to grad school in the sciences, actually you get paid to go to grad school. You're not going to be rich, but they pay you a stipend, and they pay for your schooling. So you can foreseeably go all the way through and have no debt coming out, because if you can get a scholarship or for undergraduate, and then you get paid to go to grad school, if you get admitted to a program, then there's no reason for you to go into debt. So that's a plus, particularly for the physical sciences or STEM disciplines. And then after that, you do sort of an apprenticeship. We call it a postdoc in academia, where you go and you're basically a scientist working in another professor's lab. And it's usually to learn a skill set that is related to what you want to do. And then you can merge your skill set from grad school and the postdoc to make something unique and push technology in a unique direction. And so, yeah, that was the track. After your postdoc, you apply for faculty positions, and I came to the University of Wisconsin-Madison.
Oh, well, I mean, you've been here a long time, but
not too long. 2011 is less than, I guess this is year 10. So yeah, it's getting to be a while.
Well, yeah, thank you for that breakdown. That's one thing that hasn't really been mentioned in these conversations that we've had, is people kind of talk about like just what they're doing currently. But the breakdown of what students or even adults that may be in this process currently could think about and look at for the future is always good information. Always got to share information. And so with all of that, for somebody you might have inspired today, what advice do you have for them?
Well, great. I hope somebody was inspired. That'd be great. So, my overall advice is to find your passion and develop expertise in it. So if you are interested in, for example, science and math, there are lots of programs and activities out there. Talk to your teachers, Let them know you're interested in doing these type of programs. Talk to your counselor. They can help introduce you to those types of programs that are run through, in particular, the Madison Metropolitan School District, as well as all school districts have some of these, that you can do over the summer, that you can do after school, to continue to nurture that interest and that curiosity. And then, study hard, work hard at school. Grades are important. And so if you do that process, and constantly reach out and get people to support your goals in life, then I think you'll be fine. The other important thing is to plan ahead.
Mhm.
So the earlier you know sort of which direction you want to go in your career, then the easier it is to start making decisions and taking actions to get to that point. So if you know early on that, for example, you like math and science, then I think engineering is a great place to look at, where you can basically learn how to create and develop things harnessing the natural processes, uh, um, that are available to you. So I think that's probably the best advice that I have. And people are always willing to listen to young people and try to help them along. So
Awesome. Thank you for the time. We really appreciate it, Professor Ashton. And I hope that we can connect and be able to do something like this again, and hopefully be around youth and get them to learn it a little bit more, for those that are advanced in math and science and not really sure how to go about it and what to do. And then for those at home and as our audience members, thank you so much for attending and listening to our session today. Really appreciate it. And again, if you want to tap into the conversation and ask some more questions or learn more about what's going on in the discovery building around stem cells or even outreach, please feel free to go on social media and use the hashtag Black STEAM Innovators. Outside of that, Dr. Ashton, do you have anything else for us tonight?
no, thank you, Jared, for the opportunity to come speak, and thank you for everyone who is listening, for your attention.
Awesome. Cool. Well, everybody have a good rest of your day. Thank you.